Welcome to Important Updates, your trusted source for breaking headlines, global insights, and sharp analysis from around the world. If you're new here, don't forget to hit that subscribe button so you never miss an update. You need to hear this if you're a tech enthusiast or anyone who relies on modern devices, because the future of your favorite gadgets might be about to change forever. Nearly every device we use today relies on computer chips, tiny, powerful brains that drive our digital world. From the phone in your pocket to the laptop on your desk, these chips are the invisible engines powering our lives, connecting us to information, entertainment, and each other. Yet, the company behind the most critical chip-making machine is a mystery to most. ASML, a high-tech giant based in the Netherlands, quietly shaping the future of technology from behind the scenes. ASML is the sole maker of extreme ultraviolet, or EUV, lithography machines. Devices so advanced, they're considered one of humanity's greatest engineering feats. These machines are the size of a bus, cost hundreds of millions of dollars, and require the precision of atomic-scale engineering. These machines project intricate circuit patterns onto silicon wafers, creating billions of transistors for modern microprocessors. Each wafer contains the blueprints for the chips that power everything from supercomputers to smartwatches. Without ASML's EUV technology, companies like Apple and Nvidia couldn't manufacture their most advanced chips. The latest iPhones, gaming consoles, and AI processors all depend on these cutting-edge tools to push the boundaries of performance and efficiency. This monopoly has made ASML a linchpin of the global tech economy and a focal point in a growing geopolitical struggle. The company's influence stretches far beyond the Netherlands, impacting economies and industries worldwide. The US sees ASML's technology as a choke point, controlling who can make the world's most powerful chips. By leveraging this control, the US aims to maintain its technological edge and protect national security interests. By restricting access, especially to China, the US has tried to slow its rivals' progress. Export bans and licensing restrictions have become powerful tools in this high-stakes competition. For years, this strategy worked. China lagged behind, unable to access the latest chip-making tools. The gap in technology seemed insurmountable, keeping China dependent on foreign innovation. But in early 2026, reports emerge. China may have built its own EUV machine. This news sent shockwaves through the tech world, raising questions about the future of global chip supremacy. If true, this breakthrough could upend ASML's dominance and redraw the global tech map. The balance of power in the semiconductor industry may be shifting, with new players entering the race. The chip war has entered a new phase, and the world is watching to see who will lead the next era of innovation. To grasp EUV's importance, think small, really small. We're talking about features on a scale so tiny they're measured in billionths of a meter. The world of microchips is a universe of the unimaginably minuscule. Modern chips cram billions of transistors onto a fingernail-sized silicon wafer. Each transistor acts like a microscopic switch, and the more you can fit, the faster and more powerful your device becomes. Shrinking these transistors boosts power and efficiency, but there's a catch. You can't draw lines thinner than your light's wavelength. This fundamental limit has challenged engineers for decades, pushing them to find new solutions. The industry used deep ultraviolet, DUV, light for years, but it hit a wall. DUV's wavelength was too wide for the tiniest features. As chip makers tried to push past this barrier, they found themselves running out of room to innovate. Enter extreme ultraviolet, EUV light, at just 13.5 nanometers, lets us etch impossibly fine lines. This breakthrough opened the door to a new era of miniaturization, making today's most advanced chips possible. But EUV is absorbed by almost everything, even air and glass, forcing engineers to reinvent the entire process. Every step, from generating the light to delivering it onto the wafer, had to be reimagined from scratch. ASML's solution? A laser blasts molten tin droplets, creating plasma that emits EUV light. This process is repeated thousands of times per second, producing the powerful beams needed for chip making. Ultra-smooth mirrors, not lenses, guide the light in a vacuum chamber. These mirrors must be perfectly aligned, reflecting the delicate EUV light with incredible precision. The precision is mind-boggling. Mirrors smoother than anything on Earth. Even a single speck of dust could ruin the process, so everything happens in ultra-clean environments. This is why ASML's machines are so hard to copy. The technology, engineering, and expertise required are unmatched, making these machines some of the most complex ever built. EUV unlocked the next generation of chips, and ASML alone held the key. That is, until now. Other countries and companies are racing to catch up, determined to break ASML's monopoly. The race to master EUV has become a global contest, with nations investing billions to secure their place in the future of technology. US policymakers quickly realized just how crucial EUV technology was for the future of global tech leadership. These advanced machines, capable of etching the tiniest circuits onto silicon, became a symbol of technological power. As US-China tensions rose, advanced chips became a new kind of battleground, one where innovation and national security were deeply intertwined. The US government pressured the Dutch to block ASML, the only company making EUV machines, from selling to China, arguing it was vital to protect Western interests. The Dutch government agreed, effectively cutting China off from the world's most advanced chip-making tools and halting any EUV shipments. China's chip makers, like SMIC, had to get creative. They pushed older DUV machines to their absolute limits, trying to keep up with global competitors. In response, the US doubled down, tightening restrictions and banning even some advanced DUV machines from reaching China's factories. For ASML, this meant losing access to a massive, fast-growing market and missing out on billions in potential revenue, an enormous business setback. The company warned that isolating China wouldn't stop its ambitions. Instead, it would only fuel China's determination to become self-sufficient in chip technology. These export controls were designed to contain China's rise in tech, but they also set the stage for a massive, state-backed effort to break through Western barriers. The world watched closely as China poured unprecedented resources into catching up, determined not to be left behind. The big question remained: could China really build its own EUV machine and close the gap with the West? The stakes couldn't be higher, with the future of global technology and economic power hanging in the balance. The chip war was about to escalate, and the world braced for what would come next. The export controls hit China hard. Its Made in China 2025 tech ambitions stalled as leading foundries like SMIC were locked out of cutting-edge chip making. Companies like Huawei lost access to the latest chips, crippling their smartphone business. The gap between China and global leaders like TSMC and Samsung widened. China doubled down, pouring billions into building a self-sufficient chip industry. The final, most daunting challenge: creating a homegrown EUV machine. China's answer was the 02 Special Project, a moonshot to build its own EUV machine. Top research institutes and state-owned enterprises joined forces, tackling every technical hurdle from scratch. The effort was secretive, massive, and relentless, fueled by political will and near unlimited funding. Teams worked in parallel, reverse engineering every detail they could find about ASML's technology. Skeptics doubted China could replicate the intricate supply chain and expertise. But the project pressed on, determined to break the West's technological stranglehold. The world underestimated just how far China was willing to go. By late 2025, rumors swirled. China had made a breakthrough. Reports claimed researchers had developed a stable EUV light source, a key milestone. In early 2026, the story exploded. A prototype EUV machine, built by SMEE, could print circuits at the 28-nanometer node. That's generations behind TSMC's cutting edge, but a monumental leap for China. The achievement proved China had crossed the EUV threshold. With a working platform, engineers could now iterate and improve, just as ASML did over years. The wall of restrictions had been breached. China now had a foothold in the world's most exclusive tech club. The era of a single company's monopoly was ending. The global chip industry would never be the same. For ASML, China's EUV breakthrough is a seismic shift. Its monopoly, once unchallenged, now faces a determined rival. In the short term, ASML's advanced machines remain unmatched, and demand from TSMC, Samsung, and Intel is strong. But the long-term threat is clear. China's domestic market will favor homegrown machines as they improve. ASML risks losing future sales and facing a state-backed competitor with a protected market. Prices and market share could erode as Chinese machines catch up. The policy of technology denial has backfired, creating a powerful new competitor. ASML must now push for relaxed export controls or double down on innovation to stay ahead. Either way, the era of comfortable dominance is over. The chip race is now truly global. China's EUV leap signals a new era for the semiconductor industry. The old model, globalized, interdependent, efficient, has fractured. Two parallel chip ecosystems are emerging, one led by the US and allies, the other by China. Western firms will keep collaborating at the cutting edge. China will focus on self-sufficiency. Companies may have to design different products for each market, raising costs and complexity. Innovation could slow as research is duplicated and collaboration fades. The unified global tech standard is fading. For many, choosing a side will be unavoidable. China's EUV machine is the foundation of its independent tech world. The tectonic plates of the global economy are shifting. China's EUV machine marks a new chapter in the chip war. The era of containment is over. Direct competition has begun. The US and Europe must now invest and innovate faster to keep up. China's breakthrough is a triumph, but mass production and matching ASML's performance will take years. The global chip industry is now multipolar. No single nation or company controls the future. This new era brings risks, geopolitical tension, supply chain shocks, and higher costs. But it could also spark a wave of innovation as rivals race for the next breakthrough. The quiet, predictable world of chips is gone. The future will be defined by relentless competition. The chip war is now the defining battle of the global economy. The stakes have never been higher. The world is watching what happens next.